Welcome to the 8th week. So we'll talk about RNNs here. Okay, welcome to the class. So let me share my screen. Right. First of all, let me show you the syllabus, what we have done, okay, what we have learned it. So we have seen this introduction to NLP and Enneagram models. What is this natural language processing? We have seen it. How human being understandable language, that we call it as a natural language, is processed. Okay, we are processing in the sense understanding it and even generating it also. That's what called the NLP part, right? Okay, and this enneagrams is that one. Okay, so in understanding, so how to understand this one is is a difficult task actually. So that has been solved using some simple methods called the first 1 gram or 1 word or two words or three words to capture the context actually. Okay, these are all the old techniques actually. Now that things have been changed, but still they are exist actually. Okay, So that way, this n-gram models, okay, so we have discussed, and ultimately, okay, what is the meaning of language model also we have seen over there. That is predicting the next word depending on the probability. Later we have seen the naive Bayes classification algorithm, how this naive Bayes is used for the purpose of the sentiment analysis. We have seen it. Then we have seen it how what is a text classification technique and classification, how this can be done. Before doing that one, how this latent semantic analysis and latent dirichlet allocation is applied, and what is the purpose of these things, how dimensionality reduction is going to happen, we have seen. Later we have discussed about the vectors, how words are going to be converted into semantic vectors, okay, how they will be shown, and okay, so what are the techniques are there, we have seen it here. Then TF-IDF is one of the method to represent the word in the numerical format, so that we have discussed here. And further we have discussed, okay, so word embeddings and visualizations. We have seen how word2vec converts, okay, so a text into a vector, and how these vectors are going to be shown, that okay, so the similar contextual vectors are going to be close. So these kind of things we have seen it, okay. Then sequence processing with RNNs is the point here actually. So simple recurrent networks, basics of RNNs and their applications in NLP, applications of RNN, use case of RNN in text processing, okay, implementation of sequence processing using recurrent neural network, okay. So I'll show you this one, how this recurrent neural network is going to be implemented. Then advanced part is that stacked and bidirectional RNNs, introduction to advanced RNN architectures and managing context in RNN techniques for maintaining context and sequences using RNN. Right, okay. So this LSTM and GRU also part of this only. So ultimately these three topics, Unit 7, Unit 8, Unit 9 are all together talking about the sequence processing only. Right, okay. So this is what our topic actually, okay. So especially unit wise going, okay, so topic if I discuss, okay, so that covers all these points which are essential one, right, okay. So we will talk about the RNN. So before this one, the word they are using is sequential processing or sequence processing they are calling, right, okay. So let us see that one, okay. So sequence processing. Okay, done. So right, this, little bit thicker pen we will take, sequence processing we are saying it, right, okay. So the first question is going to be, so what is a sequence? This is the question we are going to ask, right, okay. What is a sequence? Can we increase this thickness of this one? It is not sure. Right, okay. What is the sequence? Sequence is usually, okay, so text is a sequence. We need to understand it. Text is a sequence, right? How this is a sequence in the sense, we read left to right. Okay, so text is a sequence now also. Okay, so we are understanding this one. Okay, so from left to right we are reading it and we are understanding. Okay, and what is the main thing we have to digest is that, okay, so second word meaning depends on first word. This is the important characteristic of this sequence models. Okay, so we are saying that one, when we want to understand the second word, okay, so we need to know the first word. So if I say this one, okay, so if I generalize this one, okay, so previous word, okay, previous word determines the meaning of current word. So you are not going to understand the things in independently, right? Okay, so you are not understanding the things independently, you are understanding the things collectively. So see this one, this sentence. Okay, when you read only what, it is not having any meaning. When you read sequence, not having a meaning, then what is a sequence? When you read these things before, okay, so then you read this what after this, I mean the sequence or sequence before, if you have what, then it is having a meaning that we understood that one, this person is asking a question. And this kind of rules and this kind of things have been framed, okay, so centuries ago, and till then we are using it and it is evolving the languages. Okay, so similar to this is what called the sequence. Now the point is that, okay, so using NLP technique, we want to understand this sequence, understand the sequence. This is our challenge actually. Okay, so actually we want to understand, okay, so using machines actually, or using neural networks. Okay, so this is the target actually. So till now what is the neural network is, very quickly, so multi-layer perceptron is a basic neural network architecture. Okay, what it will do is that when it will take some input, this is my, I'll send the input to the neurons, and there are going to be certain hidden layers. They are all connected, fully connected, densely connected. Okay, now here I am passing the input to this one. Okay, this input is passed, and with this input, these weights are going to be, okay, through these weights this input is processed and some output is going to be given here. Okay, here actually what is the drawback is that we are unable to find the relation among the words here when we send them in sequence. Suppose here uh, today is Sunday. This is a sentence I am giving. Okay. If you do not have this today, there is no meaning for this Sunday, because Sunday can be any day. Okay, well, what is the context we are talking about this Sunday? When I say this, today is Sunday, okay, so so today we need to do some special activities. Some context is connecting with this word, okay. So suppose if I pass this thing to this network, so like two separately, day separately, is separately, and Sunday separately. And if there is no proper relation among these things in this sequence, it has, if it is not understood, like Sunday is coming, okay, so uh, earlier, and day is coming later, 2 years later, and E is coming later, then okay, so it is not going to give a big meaning for us, right? So this MLP, so MLP is not suitable, not suitable for processing sequences, processing sequences. Because first step is training. We have to train this model, okay, then we have to inference it. It has to tell something. This is the human nature, and the same thing we are expecting from the neural network, okay, training and inferencing. So this is not going to happen properly because it is not understanding well, so it cannot inference well, right? Okay, so we require some other network where recurrence should happen. Recurrence relation, what it means, that one, okay, so when you are processing, when you are processing, okay, x plus one step, okay, you will consult, x step, okay. This is what called the recurrence relation, okay. So or even finding the factorial using recurrence, what we do is that one, fact of phi you want, for this one I'll call this one, okay, like 5 into fact of 4. Then to get this one, what I will do is 4 into fact of 3. To get this, 3 into fact of 2. 2 into fact of 1. And this result is 1. So 2 into 1, okay, so this is the result of this one. What is happening here, it is, okay, cumulatively going. It means if I put them in a sequence order, okay, so fact of 5 will get from 4 into fact of, sorry, 5 into fact of 4. To get even this one, I require 4 into fact of 3. To get this one, I need 3 into fact of 2, okay. So fact of 2, then to get this one, 2 into fact of 1, and the result is 1 here. So this result will go here, and this result will go here, this result will go here, this result will go here, and you are getting the full answer, right? See, this is a sequential processing, one after other you are trying to understand. To understand this one, you need to understand this. To understand this, you need to depend, you are depending on this one. To understand this, you need to depend on this one. To understand this one, you are depending on this one. And when Okay, so you understood this one, this meaning you are attaching to this, so that you are getting, okay, so the total meaning of this one. Then you attach, okay, so you are going to get the meaning, you are going to get this meaning, you are going to get this meaning, and ultimately you are getting the, okay, so whole meaning of this particular sentence. This is how you have to understand it. Okay, this is because of this one. Okay, so it has named it as recurrent, okay, neural network, right? Okay, so this is what called the recurrent neural network. Now the point is that okay, what is the advantage of this one and how we are going to utilize this one to make understand this sequence. Okay, so what we are doing is that this is my neural network. Okay, and here I am passing the words W I. So this I is going to be 1 to n. Okay, n words I am passing. So when I am passing something, okay, so it is understanding and it is going to generate something, a meaning, intermediate meaning here. Okay, and this way it is always doing it, and ultimately it may produce, okay, some meaning here. Okay, that I can see it as, okay, so contextual meaning. Contextual meaning. So this is how we have to visualize the neural network of RNN. Okay, but here this is a bit complex thing. Okay, so to understand how these are going on, okay, so I'll give you this. Okay, so what we call unwrapping RNN, or unfolded, we call unfolded RNN, recurrent neural network. Okay, now when I unfold it, what you are going to see is that one, right? So this is taking the word one, okay, and it has understood, okay, and it is generated something, and at the same time the generated thing is passed to the right side, and this one is second word. Okay, so this second word meaning, to understand it second word, it requires a w1 also, so this is you are getting here. Okay, so now this w2 is combination of w1 and w2, right? Okay, and here you are going to get the combination meaning of w1 and w2. This is w1, and this w1 w2 is again passed here. Now we are passing it to the next word. This is going to be w3, and this w3 is a combination of w1 w2 and w3. So this way it will go on, and ultimately one, okay, so fine thing you are going to get is that, okay, so the result or the context vector. Why I am calling this as a vector, in the sense here this word one, each word is represented in the form of a vector of dimension n. Okay, so this way this 4-dimension vector is passed here and it produces a 4-dimension, then this 4 is passed and again it produces a 4-dimension, it is passed. So okay, this way some context vector of size x, okay, so it is going to generate. So you need to know that one. Now this is a combination of word 1, word 2, word 3. Okay, suppose I am going. Now it is a meaning and it has giving this meaning. This is what called the RNN. Okay, so now here, okay, so we have to map this knowledge, so this understanding, okay, it is understanding something. Okay, this knowledge I have to map to One thing is predict next word, okay, and predict label. Two things are there, okay. Either you can train this model or you use this one to predict the next word or to predict the label also. You can do any one thing. Both things we can do it, but not at a time, okay. So these two are possible things, right? Okay, so here what is ultimately happening is that, okay, so understanding text and predicting next word, okay. This is one task, understanding text, then, okay, classifying the text. So both ways it is working it, okay, understanding the text and predicting the next word. Now the point is that one, okay, so first training part, training of RNN, how this training will happen. So, and it is supervised. Supervised in the sense, what you do is that one, first you give that what is input and what is expected output. Both you will give, okay. You will give input and as well as the you will give the, okay, so expected output also. So this model, whatever the model between here, okay, the RNN will learn that how to take this input and how to map it to this output. So this will map. So this relation is identified between the input and the output. The relation is captured. Whether it is predicting the next word or, okay, so classification, all is happening is that, okay, so it is trying to find out the relation. With this one, what we are saying is that one, this RNN has understood, okay, so the meaning or the relation between these things, and based on that one, this RNN will produce the text or it is going to do the classification task, okay. That is what is happening here. So now the RNN will, so what we do is that one, suppose we have some okay, let's take classification task, which is very easy one, classification, okay. So what we do is that one, so let us say this movie is good and its class is going to be positive class. It is talking in a positive way. This movie is worst. It is talking negative sense. So my point is that when this is my sequence, this is my sequence. This sequence has to be understood by my RNN. Okay. So this we are passing it and it is understanding it and it is, okay. This understanding it is mapping it to, okay. So two things only it is having, okay. So whether positive or negative. So whatever it has understood, from this one, it is mapping this to either positive or negative one. Okay. This way, it is understanding this relationship between this sentence and this class, this sentence and this class. If you observe, for good, the vector will be different. For the worse, the vector will be different. So when you attach this vector to these things, okay, so it is going to, the RNN is going to understand something else, and it maps that one to this negative one. Actually, to map this one, what it is doing is, it is okay, it is adjusting, it is adjusting, okay, so parameters, because the RNN have the weights, parameters or weights it is having. So these weights are going to be understood, or they are going to be uh, trained or adjusted, we call. Okay, so again here we use the same algorithm called the back propagation technique. Okay, we use this back propagation. What you do in this back propagation is that okay, so this is my network. You are giving the x part, and it is generating y hat, and y is original one. So in back propagation, we will calculate loss equal to y hat minus y whole square. Okay, so this is my loss function. So using this loss function, it calculated the loss. Then we do is that dl by dw. This w is a parameter. So with respect to this w, I am going to derive this l, so that I am going to get some gradient or the different. Okay, and using this gradient, what I'm going to do is that I'm going to update weight. So I'm adjusting this weight. So w new equal to w old minus learning rate into dl by dw. This is what the formula. Okay, this way the weights are going to be understood or trained or adjusted. This way, this RNN, whatever the weights it is having, okay, this RNN, recurrent neural network, it will be, okay, so managed, or it will be understood, it will be adjusted, these weights. So this is going to be a model that understands the positiveness and the negativeness. Okay, so now what is the task is that one, we are going to give text, and we expect its emotion, whether it is sad emotion or happy emotion or exclamatory, what it is going to tell. Let us see the syllabus. What is we have? See, simple recurrent neural network, basics of RNN and applications, and applications of RNN, use case of text processing, right? Okay. So here, lot of styles have been come into the picture here. One thing is, I said regression, okay, and another I said that one classification. Regression and the classification. In regression, what you do is that one, same you do this, okay, but the prediction is going to be a numerical value. And here the same concept here. So the prediction is going to be a word. So this way, what it is predicting, depending on that one, the names have been changed, regression and the classification. That is the only difference here. Now we have understood that one, what is RNN, and okay, so what is the regression part. Okay, so now types of RNNs. What are the different types are available here? Okay, so here one-to-one is possible. It means that you will give one word and you will expect word one. This is no big use, because a text can be cannot be understood with single word, right? Okay, then one to many, very popular thing here. Okay, you will give one word and it produces a number of words. Okay, this is actually what is happening in text generation. So text generation is a big example. Text generation is a big task. Okay, similarly, many to one. Many to one in the sense you are going to give multiple things. Okay, all these multiple things will help to predict only single word. So this is what called the many to one concept. This is regression or classification. Currently we are talking about, okay, so this one only. Regression and the classification we are talking about, right? So this is what the concept here. Okay, so and many to many is also there, where you will pass many things and you will get many. This is for the purpose of the translation, language translation. Okay, so this way we have different types of RNNs, recurrent neural networks. Okay, so yeah, this is what NLP, the purpose of this RNN. Okay, so text translation and text classification are the biggest challenges in RNN. Okay, let us see that. Okay, so how to build this RNN in programming, right? Okay, and advanced RNNs we'll see it later. Okay, let me take you to my collab sheet. Let's go to collab. Okay, let me take you to one more profile of mine. It's okay. So NLP lab experiments. So with RNNs, and let's see this program. So here, so natural language processing. Okay, so is a discipline in, okay, so recurrent neural network. So we'll see the RNN, sentiment analysis and character generation. Okay, so first you need to understand that text encoding actually. anyways fine. Okay, so I'll directly take you to the code of the RNN, how RNN is going to be built. Yeah, this is the structure of the RNN. Just now I have shown you. This is the input. I'm going to pass it and I'm going to get the outputs here, and here also I'm going to get.